we've been looking at a few different types of problems over the last couple of weeks. A lot of percent problems. We also used something called a proportion, which we did in the opener today. We solved some proportions. We use proportions to solve certain types of word problems using percents. We talked this week more specifically about what proportions are. So let's review a little bit of that, and then we're going to use a lot of that information to solve some other types of problems that are going to involve proportions, but they're going to be more in a realistic situation. So first of all, what is a ratio? This is an important idea, something we need for proportions. We talked about it earlier this week. What is a ratio? We're going to use a fraction to express a ratio, but what is a ratio? So a ratio is a comparison of two things, specifically two quantities. So it's and we wrote this down on Monday, but we're going to write it down again here, a comparison of two quantities. Talk about that word in a second. It's a fun one. Quantities using a fraction. Now, you don't have to use a fraction to write a ratio. We're going to use fractions because it makes things easier to work with, especially when we start using ratios with proportions. Because a proportion is what? When two ratios are equal to each other. All right, now we're going to be doing some problems today that are going to involve ratios, but they're going to be more than just a regular fraction like 2/3. All right, what we're going to be looking at today would be something like, say, 2 apples over $3. And so what this ratio represents is, instead of just being the ratio 2/3, or a number 2/3, it actually has some meaning now. What might this fraction here mean now that I've put those apples and dollars on there? So this fraction, or this ratio, might mean that 2 apples cost $3. So what we do is we take the numbers in the problem and we give those numbers meaning by putting units on them. So units are just a way of measuring or counting things. So this right here is a ratio of two quantities. And quantities, when we use this word quantities, we're talking about a number, but specifically we're talking about a number of something. So how much of something there is. So one quantity would be 2 apples, how many apples there are. Another quantity would be $3, which would be how many dollars there are. All right, so what we're going to be doing in these word problems is we're not just going to be looking at the ratio of numbers, but we're going to be looking at a ratio of quantities, which include units also. Yeah, so that brings us to the ratio of units. So a ratio of units is actually not going to involve numbers at all. All right, so it's a ratio. What's a ratio? Comparison of two quantities using a fraction. Instead of comparing quantities and a ratio of units, we're just going to compare units. All right, so let's write that down first. It's a comparison of units. And before we finish that, let's talk about what these units are. Can somebody give me some examples of units? We just use 2 of them. What were the 2 units I used in the last example? Apples and dollars, right? So those would be units. So apples would just be counting things. So anything you could count. So apples, calculators, pencils, folders, whatever. Those are units. You could even use units as like people. People would be a unit. Dollars is how much something costs. You could also have units that like measure something, like the length of something. What kind of units would we use for measuring the length of something? A ruler, but what kind of units? We would use a ruler, but we could use inches or centimeters or meters, or let's think bigger scale, like you're driving in a car. What kind of units would you use for a length? You might use miles or kilometers. Okay, what's something else we can measure? Say volume. Volume is how much space something takes up. So you might have how would you measure the volume of like a milk jug? What kind of units might you use? You could use liters or quarts or gallons. So these would be measures of volume, how much space something takes up. We could also measure, we can measure area. So if we talk about area, like how much space this floor covers, if you look at the tiles on the floor, each one is 1 foot by 1 foot. It's a square, so we call them square feet. So that would be area. Most area measurements are square something, so we have square feet, or square miles might be measuring how much land there is, or acres would be a measure of area also, square inches, square centimeters. We could measure time, how long something takes. How would we measure time? What kind of units would we use for that? Seconds, minutes, hours. Okay, those are all units. Okay, so anything you can measure, anything you can count, we would have units to describe what those numbers mean. All right, if we say an amount of time and just say 3, we don't know if it's 3 seconds or 3 hours or 3 days or 3 years, so those units are really important. All right, so going back to this idea of a ratio of units. It's a comparison of units using a fraction, just like we've done with other ratios. So let's add that on there, using a fraction. So let's look at a couple examples. Let's say, like we had before, we had apples and dollars. So a ratio of units, instead of saying 2 apples over $3, the ratio of units would just be apples over dollars. All right, let's think of some other ones that you might use in the real world, other ratios of units. How about miles over gallons? What might this ratio of units be useful for? If we're talking about the efficiency of a car, how far the car can go for every gallon you put in it, you might have like a hybrid car that gets 50 miles per gallon. That's pretty good. So you only have to buy 1 gallon of gas and it'll drive 50 miles. Now, you don't typically just put 1 gallon in there and then drive 50 miles and then get another gallon and put it in there. So we have this ratio of units that'll tell us miles over gallons, and it doesn't have to be 1 gallon. It could be any number of gallons and any number of miles. So you might have like 50 miles per gallon. Or you might have a big truck that doesn't do so well and is like 14 miles per gallon. All right, so that measures the efficiency of the car and how far it can go for each gallon that you put in there. And the way we read that is not miles over gallons, but how do we usually say this mileage? Miles per gallon, right? So this fraction here, we read this, and we've seen this before, and like percents, we read that as per. So we would say miles per gallon. Can you think of another ratio of units that uses this per involving cars? So miles per hour is usually abbreviated mph, right? But if we wanted to write it as a ratio of units, instead of saying miles per hour or writing mph, we could write that as a fraction that would look like what? Miles over hours. And basically what that says is, if you're going 60 miles per hour, in 1 hour, if you're going at that speed, you would drive 60 miles, right? But if you're going 60 miles per hour and you go 2 hours, then you're going to go twice as far as you would go in 1 hour. Notice, though, that all of these examples here have different types of units that we're comparing. So we have apples and dollars. We have miles and gallons. Those are both units that we listed over here. Miles and hours. Those are both units. All right, so miles is a unit of length. Hours is a unit of time. But we're comparing those two things and see how they relate to each other in specific situations. All right, so couple other, let's see if I have any other examples on here. We did miles per hour, we did miles per gallon. Dollars per pencil. You guys would, if you have to buy a pencil in here, it costs how much? $10, right? So if you want to buy like 5 pencils, you might write a ratio that would be $50 per 5 pencils. All right, but we can think about that as a ratio of units, dollars per pencil. All right, so any two things that you can measure or count, you can compare to each other if they're related to each other in some way. All right, so first problem, first example, we have a map of the state of Illinois. The map is obviously smaller than the state of Illinois, right? The state of Illinois is pretty big. If we want to look at a map, we need a smaller version of it. So the map is going to have a scale. So let's say that the scale of the map, which tells us how big things represent on the map, or how big things are in the map, says 3/4 of an inch represents 12 miles. All right, so on the map, 3/4 of an inch, it's a little bit less than an inch, is the same thing as 12 miles in the real world. We want to know if it's 9 inches on the map from Belleville to Champaign, which is a city in central Illinois, what is the actual distance in miles? So if we were actually going to walk from Belleville to Champaign or drive or whatever, how far would that be? All right, so there's a few things that we're going to do to set this up. The first thing we're going to do is we're going to write what we were talking about just now, a ratio of units. So we're going to start here by writing ratio of units. And you're not going to have to write that out every time, but you're going to want to indicate what it is that we're finding. So we're going to write a ratio of units. And when we do this, we're looking for 2 units in this problem that are being compared to each other. So in this problem, do you guys see 2 units that are being compared to each other? I think I heard somebody say miles. That would be one type of units. What else? So we're just looking at the units right now, not the actual numbers, but just the units. And the other one would be inches. All right, so this inches specifically would be inches on the map, and the miles specifically would be miles in the real world. We wouldn't be talking about miles on a map because miles on a map would be a really big map, right? We're measuring things in miles on a map. So on the map, we're going to be measuring things in inches. So we're going to write a ratio of units. It doesn't matter which units we put on top. I usually just put the first one in the problem on top and the second one in the problem on the bottom. So I'm going to put inches on top, and I'm going to put miles on the bottom. Now I'm going to clarify. I'm going to just be a little bit more specific. The inches I'm going to put on the map. So I'm just going to put map in parentheses there. And then for miles, I'm going to put world, meaning number of miles in the real world. And so these are 2 units that are related to each other in this problem. So we're going to write this ratio of units. Notice that there's no numbers here yet, right? With this ratio of units, we're going to write 2 ratios that involve numbers. One of the ratios, we're going to call it the ratio that we know. I'm going to label both of these ratios here. So the first ratio, we're going to have 2 numbers that go together that we know. All right, and I'm going to make a fraction here. It's going to have a top and a bottom. And let's look at the problem here, the setup of the problem. What 2 numbers involving inches and miles do I know go together? This is a little bit tricky. It's actually not the 12 and the 9, because the 12 miles and the 9 inches don't go together. 12 miles in the real life don't correspond to 9 inches in the map. Yeah, it's actually going to be 3/4, and it's a little tricky because it's not written as a number, but it's going to be the 3/4 and the 12 miles. So 3/4 of an inch in the map is the same thing as 12 miles in real life. So I'm going to write those 2 things in this fraction, but it's really important that I write them in the correct place. Which one do you think should go on top? When we're deciding what goes on top and on the bottom, we want to look at our ratio of units. Notice that in our ratio of units, we put inches on top and miles on the bottom. So the inches, that right here is 3/4, that's going to go on top. So 3/4 goes on top because that's inches. And then on the bottom is going to be the miles that go with a 3/4 of an inch, which is 12. So in the problem, it tells us that 3/4 of an inch represents 12 miles. We know those go together. And then we know the 3/4 goes on top because that's a number of inches. And in our ratio of units, we said inches are going to go on top. So for this whole problem, everything we do, inches are going to go on top, miles are going to go on the bottom. All right, the other ratio that we're going to write is going to have something in it that we need. It has actually, it's going to have 2 parts. One part we're going to know, but one part we need to know. We're trying to find out. All right. Let's first, though, put in this ratio what we do know. So in the question it says it's approximately 9 inches from Belleville to Champaign on the map. So where's that 9 inches going to go? That's going to go on top because it is inches, right? So since it's inches, it goes on top where the inches go. On the bottom, Yeah, on the bottom, we don't know what goes here. Now, I'm going to put a question mark, but don't put a question mark on yours. We don't know that, but we want to know how many miles it is, the actual distance. All right, so I'm going to put a variable there instead of a question mark, because question marks aren't that easy to work with. And maybe pick a variable that is relevant to the problem. I'm going to use D for distance. All right, you could put M for miles if you want. Although we have two different things going on with miles. We have 12 miles and then the miles that we're trying to find. So I like D for distance, but it doesn't matter as long as you just pick a variable, and then we want to solve for it. All right, now, I put an equal sign between these two ratios because I know that they are equal to each other. All right, anytime in this map we divide inches in the map by miles in real life, it's always going to equal the same thing. All right, that's what it means to be proportional. So now we're going to solve this proportion. The math part here might be a little tricky because we have the fraction, but let's do what? How do we solve a proportion? Cross multiply. 3/4 times D is 3/4 D. And 12 times 9 is 108. Then we're going to circle our variable and draw our line of equality. And I'm going to give you guys a shortcut here. Most of the problems we're going to do, in fact, this is the only one that's going to have a fraction in it. So if you don't remember this, it's okay. But we're going to divide by 3/4, right? Yeah. But dividing by 3/4, remember what you do when you divide a fraction? Divide by a fraction?
Multiply by.
You guys remember KFC? Keep one, flip the other, and then change to, what are we changing? From division into multiplication. So instead of dividing by 3/4, I'm going to flip it and I'm going to multiply by 4/3. Now what's going to happen here by doing that is the 4 on top cancels with the 4 on the bottom, the 3 on top cancels with the 3 on the bottom. So it's going to cancel out that 3/4 just like we want it to. However, since I multiplied by 4/3 on the left, I have to multiply by 4/3 on the right. All right, so on the left side, those 4/3 cancel each other out, and that leaves D, the distance that we're looking for. And then on the right side, we have 108 times 4/3. So to multiply a whole number times a fraction, we take the whole number times the top, the numerator, 108 times 4, and then we divide by the denominator. So it's going to be 108 times 4 divided by 3, and that's going to give us what? 144. Now we're not quite done. Don't box your answer yet. Why aren't we done yet? What are we going to want to put with our answer? What do you think? Miles, right? So we always want to put units on our answers when we're doing these problems. How do I know that this is 144 miles? It's actually two things that we could look at here in the problem and in our setup that's going to tell us this is miles. One reason I know that this should be miles is that the question asks, what is the distance in miles? So our answer should be in the units that it's asking for. It should be in miles. Now, what is it in my work that says that this is miles here? That D is going to be a miles unit. Where is D in my fraction here? Yeah, D's on the bottom. And in my ratio of units, miles are on the bottom. So I know that whatever I get for D should be a number of miles. So that tells me that this answer is going to be in miles. All right, so when we're doing these word problems, it's important that we put units on there because if we just say 144, we don't know if it's 144 inches or 144 miles or 144 gallons or whatever. We always want to put units to make sure we're clear about what that answer means. And then, as usual, make sure you box your answer. So moving on to the second example. This one will be a little easier as far as the math goes. All right, so in this example, we have a basketball player, and she's shooting free throws. She makes 7 free throws out of every 9 that she takes. We want to know that over the course of the season, if she shoots 216 free throws, how many is she going to make out of those 216? All right, so what are we going to start with? What are we going to do first? We're going to write a ratio of units. So last time we wrote out ratio of units. This time let's just call it ROU, ratio of units. All right, our ratio of units is going to include 2 units in this problem that are being compared to each other. Now this one's a little tricky because she's shooting free throws. So both of the units that we're going to use are going to involve free throws. So free throws wouldn't be a very good unit here. What are the 2 things about the free throws that we're comparing? How many she makes and how many she takes. All right, so on one of them we'll call made free throws, and I'm just going to abbreviate free throws FT. So one of them is going to be made free throws. The other one I'm going to use attempted free throws. All right, attempted just means that it's how many she takes. So for the rest of the problem, when I set up my ratios, I'm going to have made free throws on top and attempted free throws or total free throws on the bottom. All right, so now we're going to write two ratios. The first ratio is going to have two things that we know go together. What two numbers in this problem go together? The 7 and the 9, right? So it says she makes 7 out of every 9. Is the 7 made or is the 7 attempted?
Made.
7 is made, so that's going to go on top. And then the 9 is hopefully attempted, right?
Yep.
Yeah, so for every 9 that she attempts, she makes 7 of them. So we get 7 over 9 for that ratio that we know. We know those 7 and the 9 go together. All right, then the other part, something that we're going to need is going to be in this ratio. And we know one part of this ratio. What do we know? The 216. Is that going to be 216 made or 216 attempted? Attempted, right? So it says if she shoots 216 free throws, that's just how many she's trying to take. So that's going to be attempted, which goes where? Top or bottom? Bottom. All right. Then the question says, how many of those would you expect her to make? We don't know how many she made, so that's going to be what we're looking for here. That's going to be our question mark. But instead of a question mark, we're going to put a variable. M for made? Oh. So I'll use M. Again, you can use any variable you want and put an equal sign between them. So now to solve this proportion, what are we going to do? Cross multiply. So we multiply 9 times M and get 9M. We multiply 7 times 216 and get 1,512. All right, so we get 9M equals 1,512. And then we solve this just like any other equation. So we circle our variable, draw our line, and then divide by 9. So divide by 9 on each side. 9's cancel on the left, leaves M. On the right side, 1,512 divided by 9 is 168. We don't even need to do any rounding here, do we? Now, we're not done. Remember, we always have units here. And we're not just going to say 168 free throws because we don't know if that's how many she tried to take or how many she actually made. So we're going to put 168 made free throws. Does this answer make sense relative to how many she tried to take? So she took 216. Is it possible for her to make 168? Yeah, it's possible. Let me ask this a different way. Let's say we got a different answer like 300. So if we said that she made 300 free throws, would that be possible? Why not? She only shot 216 of them, right? So when we get an answer with these problems, make sure it makes sense in the context of the problem. If we say that she made 300 free throws when she only tried to take 216, that doesn't make sense, right? And that's the kind of answer we would get if we mix something up when we're setting it up. All right, if we put the 9 on top and the 7 on the bottom, or if we put the 216 on top and the variable on the bottom, then we would get an answer that wouldn't make sense in this problem. It would be too big. So we want to make sure that it at least makes sense in the context of the problem. It doesn't necessarily mean that it's right, but it's just a quick way to check and make sure that it's at least plausible. All right, the last problem here actually has two parts. This involves the Indianapolis 500, which is a NASCAR race, right? They drive around a track a bunch of times, and they do it for a few hours, and it's really exciting, right? I would get bored. But anyway, the race is 500 miles long, and so when the record was set, it was kind of a long time ago, almost 30 years ago now, in 1990, the driver, Arie Luyendyk, was driving 13.442 miles every 5 minutes. All right, so there's two things that we want to ask here, or two things that we're going to try to answer. One is how many miles he could go in 1 hour, And then the other one is how long did it take him to finish the race, because the race is 500 miles. All right, so we're going to answer those two questions here. For both of them, we're going to use the same ratio of units. So let's start part A with that. We're going to write a ratio of units here. And what two units do we have compared to each other in this problem? All right, we have miles and minutes, right? So we're going to have miles, how far he drives, and minutes, how long he's driving. Okay, so we have distance on top, and we have time on the bottom. Then we're going to set up two ratios. First ratio is going to have two parts that we know go together. So what two things in this problem do we know go together? What two numbers go together that involve miles and minutes?
13.442 and 5.
Okay, 13.442 miles and 5 minutes. Which of those is going to go on top?
13.442.
Yeah, the miles are going to go on top. So 13.442 goes on top. And the number of minutes is going to go on the bottom, which is 5. So every 5 minutes, he's driving 13.442 miles. So these two go together. That's one of our ratios. And again, we're using this ratio of units to decide which one goes on top so that we don't get our units mixed up here. The other ratio that we're going to write involves something that we're trying to find, something that we need to find here. But we do know one thing. Now, this one's a little tricky. But let's look at the question for part A. It says, at that rate, how many miles could he travel in 1 hour? So what does this part of the problem tell us? Does it tell us a number of miles or a number of minutes?
The number of miles.
It gives us minutes, right? But it doesn't give it to us in minutes. It gives it to us in hours. It is a little tricky here because it's not giving us one of the units that we're using. But think about this as distance that he's driving, and this is the time that he's driving. And so in this question here, it's asking in this amount of time, 1 hour, how far can he go? So instead of using 1 hour, though, I don't want to put 1 hour in my ratio. What's the problem with that? Well, our ratio of units has what in it? Has minutes. So instead of putting 1 in there, I'm going to put 60 minutes. So 1 hour is the same thing as 60 minutes. So we're going to change that hour to minutes so that we can put it in this ratio and use it. So this is going to be 60 on the bottom. Why did I put it on the bottom?
Because that's the minute.
That's where we have minutes in the ratio of units. And then on top we're going to have a variable that we don't know. We're trying to figure out how far he went during that time, so I'm going to use D for distance. You can use M for miles. The thing I don't like about M in this problem is that could be minutes also. So I'm going to use D for distance. All right, we'll set those equal to each other and then solve by cross multiplying. We get 5D equals, I'm going to need some help from a calculator here, 13.442 times 60, 806 point what?
5.2, sorry. I was looking at
5.2?
2. Yeah.
Then solve, we circle variable, draw the line, divide by 5. 5's cancel, and we get D equals,
Or M.
okay, now we're not quite done. D is on top of the fraction, which means the units should be miles. So I'm going to make sure I put that in there, and that makes sense for the question because it says how many miles could he travel. So the answer is going to be 161.304 miles. Now, real quick, before we move on to the next one, we're talking about how many miles he drives in 1 hour. So this 161.304 miles is actually how fast he's going, right? Because it's miles per 1 hour. So he's driving 161 miles per hour during the race. And that's his average speed. That's including stops and everything. So that's pretty fast. I've never driven that fast.
That's how fast I drive to school every day.
All right, second part here, it says how long would it take him to drive 500 miles? So this time we're looking for how much time it's going to take to finish the race, drive the 500 miles. So we're going to use the same ratio of units. You don't need to rewrite it because we're going to use it from part A. But we do need to write the two ratios, one that we know and one that has something that we need to know. The one that we know is actually going to be the same. It's coming from the setup of the problem, the 13.442 miles for every 5 minutes. So that part's going to be the same, 13.442 for every 5 minutes. But then this time the given information is different. Instead of the amount of time, now we have the distance, right? So where's that 500 going to go?
On top.
That goes on top because we have miles on top. Exactly. So the 500 goes on top, and the amount of time it's going to take him, I'll call it T. You could call it something else. If you used M in part A, you would not want to use M in part B because those would represent two different things. So this is why I use D in the first one and T in the second one, so we don't get confused with miles and minutes. Cross multiply. 13.442 T equals about 2,500. All right, cool. We want to get that T by itself. Draw your line. Divide by 13.442. Just a heads up, we're going to get a big long decimal. Let's round this to the nearest hundredth. All right, so we're talking about the number of minutes. We'll round to the nearest hundredth. It's not going to be minutes and seconds. Keep that in mind. It's just going to be the number of minutes. And so we get T is equal to...
0.00.
Nope.
185.9842.
984 and so on. Since we're going to round to the nearest hundredth, that would be the 8 here. We get rid of the 4 and everything after it. Is that 8 going to stay the same or go up? It's going to stay the same. So we can actually just write it down like this. And the units are going to be minutes. So it's taken him 186 minutes, roughly. Quick question about this. How much time is that?
Like 2 hours.
1 hour, 2 hours, 3 hours, 4 hours? It's about 3 hours, right? So an hour is 60 minutes. 60 times 3 is 180, so it's 3 hours and 6 minutes. So he drove 500 miles in a little over 3 hours. Just to kind of give you a comparison, Chicago's 300 miles away, so that's 200 miles less, and it usually takes, if you drive to Chicago, probably take you about 5 hours. So he's going pretty fast.